this video is to serve as an introduction to some basics about sets. So we're going to go over some definitions, some terminology, so that you can understand what I'm talking about as we go through this lesson and future lessons regarding sets. So a set is a collection of objects called elements, and a set can be described in words, or it can be described in roster form using curly brackets. This little E, it looks like an E, means that something is an element of a given set. Sets are often named using uppercase letters. A universal set is a set that includes every possible option in the scenario you are considering. So, for example, you might say you're only considering real numbers. You'll hear that a lot in math classes, which means you're not looking at complex numbers like with a little I. You're just looking at the set of real numbers, and that's all you're considering. So a universal set would include every possible option in whatever scenario you're considering at that point. An empty set is a set that contains no elements. You can represent that with, it looks like a zero with a line through it. That means the empty set or the null set. Let me spell that out. So the empty set or the null set can be given by that little zero looking thing, or it can be given by a set of curly brackets with no elements listed. There is a subset and there's a proper subset. And so what I want to point out are the two symbols used for those. A subset can be the exact same set. So let's think of an example. The set with the element 1 is a subset of the set with elements 1, 2, 3, because 1 is contained within the set 1, 2, 3. So it's a subset. More specifically, that same example we could say is a proper subset because it's not the same set. These, think of them like this, right? The set that contains element 1 is less than or equal to the other set, but it's also strictly less than, right? It has the same elements but less. Another example is, you could say 1 compared to 1. This is not less than or equal to, right? It's not a subset, or it's not a proper subset, I should say. It would be a subset. So I could say 1 is a subset of the set that contains 1, but I couldn't say it's a proper subset. Okay, so it's not a proper subset. And that's because if they're the same exact set, it's still a subset of itself, but it's not a proper subset. So a proper subset has fewer elements than the original set. Okay, so let's use those ideas to answer the following questions. So given U, the U is going to be your universal set. So if the universal set is lowercase letters in the English alphabet, and set A is A, E, I, O, U, set B is M, A, T, H, set C is T, H, O, M, A, S, and set D is M, A, T, H. Answer the following. So part A, describe set A in words. So right now, set A is defined using this roster notation where every element is listed in curly brackets, but we could describe that in words, right? We would say A, E, I, O, U is the set of vowels. So you say vowels, you could be more specific and say lowercase vowels or lowercase letters in the English alphabet that are also vowels, anything like that, but basically vowels. B, is B a subset, and this is actually a proper subset, is B a proper subset of U? So is B a proper subset of U? So B is MATH, and I want to know if that's a subset of lowercase letters in the English alphabet. So in order for that to be true, all of the elements in set B would have to also be in set U, and that is true. So is B a subset or a proper subset of U? Yes. Is B a proper subset of C? So B are the letters that spell math. And I want to know if that's a proper subset of C, which are the letters that spell Thomas. Okay, so if I look at that, every letter in the first, or every element in the first set has to also be in the second set. So I have an M, that's also in the second set. I have an A, that's also in the second set. I have a T, that's in the second set. And I have an H, that's in the second set. There are fewer elements in B than there are C. So that means I can say, yes, this is a proper subset. So B is a proper subset of C. So order doesn't matter. It just matters that they are listed. Each element is listed in both sets. Okay, is C a proper subset of B? So this is backwards, right? So now it's asking, is C a proper subset of B? So everything in the first set must also be in the second set. And you can already tell that that's not true. We've got this S here, and there's no S in the second set. So this is not true. So no, C is not a proper subset of B. Is D a proper subset of B? So D, notice D and B are actually the same set. They're both the letters that spell math. So is D a proper subset of B? No, it's not, because they're exactly the same. Remember, to be a proper subset, you have to have fewer elements in the first set. Now, D is a subset of B. If it had the line underneath it, that would be true, but it's not a proper subset. All right, part F. Is A an element of set A? So is A an element of set A? If we look at set A, we can see that there is an A there. So the answer is yes. A is an element of set A. Part G. Is P an element of set C? If you look in set C, there is no P listed there, so no. So as long as you know what the symbols mean, you'll be fine. It's not really a difficult concept to understand elements within sets, and sets having the same elements or not having the same elements. It's just getting to know the terminology, getting to know the symbols, etc. Okay, let's look at 2, 3, and 4. List out the elements of the set days of the week. So this set is described in words, and what I want to do is give it in roster form. So I would put curly brackets, and I would just write them out. So Monday, Tuesday, Wednesday, Thursday, Friday, and I should have started further back so that I could have enough room to write it all on the same line, but Saturday and Sunday. And that would be it. List out the elements of the set even numbers between 1 and 15. All right, so I can list those out. That'll be 2, 4, 6, 8, 10, 12, 14, and that would be it. So those are all the even numbers between 1 and 15. So you can see that sets can be given in different ways. So again, 2 and 3 are given to you in word form, right? They're a description. And then it's asking you to give it in roster form, which is another way to say list out the elements. Number 4, define a universal set that could contain each of these sets. So set A contains dolphins and bears, and set B contains lions, bengals, and bears. So think of a set that can contain all of those elements. So there are a couple of options. One option you might see, and so there's not one specific answer, there's several answers. The universal set could be mammals. So all of those listed are mammals. A dolphin, a bear, a lion, a bengal, and then a bear is listed again. So that's one option. Another option you might see is NFL teams. Or I could say NFL teams or mascots. So, as long as all of those elements live within that realm, it's fine to define your universal set in that way.